All right, we are recording. So today we are discussing adding even more options to our if and else statements. So last class we discussed using if and else statements to decide between two options. We had our condition. If that condition was true, we did whatever was in the if body. If that condition was false, we did whatever was in the else body. And then after that, whichever branch we took, we would resume our program after that. So that's great when we only have two options, but what if I want to choose between more than two choices? Well, we're going to use something which is going to combine the powers of both if and else. If you're not aware, this is Captain Planet. I haven't actually seen Captain Planet myself, but that's the catchphrase from the show, by our powers combined. So, else if statements are going to combine the useful powers of both if and else statements. Just like if statements, else ifs will use a condition to check whether or not their body should run. And like else statements, else ifs will only check that condition when the condition of the if above them was false. So let's look at how that would look. Here's how this general structure of an else if looks. We've still got our if condition. When this condition is true, we're going to run our if body, and that's it. That's the only code that's going to run here. When that condition is false, so if my condition is false, then we're going to check our second condition. If that condition is true, then we will run our else if body. And if that second condition is false, then we will actually run the code inside of our final else. So we're making more of a sequence. We can go down, checking multiple conditions one at a time. But if my initial condition was true, if this one was true and I did this, none of the rest of this matters. So none of that's going to run because we entered our if. We don't need to check any of the else anything. So that's how we can incorporate an else if. If we look at how the flow chart for that would look, we've got any of our code before our if, just like normal. We've got our if condition. So if that's true, we're going to follow our true branch, run the body of our if statement, and then our program will continue. If our condition is false, we're going to follow this branch, and then we're going to check a second condition. We're going to check our else ifs condition. If that else ifs condition is true, we'll follow that branch, do the body of the else if, and then we will resume our program after that. If our else if condition is false, we're going to follow that branch and run the else. And then our program will continue after that. Now, it should be noted, you can have as many else ifs within one sequence as you want. So I can have an if in a diamond, and then I can have an else if, and then another else if, and then another else if. We can have as many else ifs within our sequence as we want. We're just going to continue down our false chain. If our condition was false, we'll keep checking that next else if. And then last, we'll have our actual else and all roads are going to lead to the same place. So if we ever have one of our conditions be true, we'll end up down at the bottom in our normal program continuing area, but we can have as many else ifs as we want within a single chain. Welcome back. All right, so does adding else ifs make sense? Very similar to other languages, except instead of combining the words into one word, we just use both words. So let's adjust our add tip method from last class. Because last class we made the add tip method where if there were 8 or more people, there was a 25% tip. Otherwise, there was just a 20% tip. So let's change it so that if there is a group of 4 or more, then they get the 20% tip. And if they do not have 4 or more people, they get no extra charge. So no bonus is added to our customers with 3 or less people in their party. So if I look at, this is our code from last time. We have our void add tip. If our number of customers was greater than or equal to 8, we said our meal cost is going to be 25% higher. Otherwise, our meal cost is going to increase by 1.2. So if I want to add the condition that if the group is between 4 and 8, I can add that else if in the middle. So if my number of customers is greater than or equal to 8, then increase the meal cost by 25%. Otherwise, if my number of customers is greater than or equal to 4, if I have somewhere between 4 and 8, then increase by 20%. And if neither of those was true, we're going to increase our meal cost by 1 time, which is essentially nothing. We're not increasing our meal cost at all. It is important to remember that sequencing matters. The order in which you check things is very important because only one of those blocks can run. We can have their conditions be exclusive to each other. So we have our first condition was num customers greater than or equal to 8. Our second condition was num customers greater than or equal to 4. Any number that is greater than or equal to 8 will also be greater than or equal to 4. But when this condition is true, we're never going to check this second condition. So if my number was 12, 12 is both greater than 8 and greater than 4. But when this condition happens, we never check this one. So that gives us that mutual exclusion. So we know this check is only actually going to check between 7 and 4, right? Does that make sense how we can make that exclusion happen? So let's look at what would happen if we swapped it around. If I check that num customers is greater than or equal to 4 first, there's no way that this block of code is ever going to run. We're never going to check this condition, or that condition can never be true when this condition was false. It's not possible for a number to be not bigger than 4, but also be bigger than 8. So we want to make sure that we're checking things in the right order so that we are actually excluding options each time rather than preventing an option from even happening. All right, so let's just look at what would happen in, let's run through an example. So let's say my number of customers is 6 and my current meal cost is 100. So when I call add tip, first I'm going to check is num customers greater than or equal to 8. So is 6 greater than or equal to 8? Doesn't look like it to me. So that's going to be false. So since our if condition was false, we're going to check the else if condition. Is 6 greater than or equal to 4? I think it is. 6 is greater than or equal to 4. That's going to be true. We're going to multiply our cost by 1.2 and save it. So our meal cost is now 120. Since this condition was true, we're just going to skip the else. So if we look at the flow chart of this program in particular, this method call, we're checking, is the number of customers greater than or equal to 8? If that's true, we increase by 25% and end the method. If the number of customers is less than 8, check, is it more than or equal to 4? If there are 4 or more, increase by 20%, end the method. If there are 3 or less, multiply by 1 and end the method. Does that sequence make sense? Sweet. All right, so is there anything being accomplished by this else statement? Since I'm multiplying by 1, is there anything happening here? Not really, right? This else is kind of redundant. So it's totally possible to use if and else if statements without the need for an else, for a catch-all else bucket. So we can use both if and else if, absolutely fine. We do not need an else. We can use an else, we can choose not to use an else, whatever we want. All options are on the table. And like I said before, we can use as many else if statements as we want after a single if. But keep in mind, only one of these bodies is able to actually run at any given time. Yeah, each time my method is called, only one of those branches is going to get followed. So if we look at our 3 different pieces for building a conditional statement, we have our if, or our else if, and our else. We need an if we are going to do any conditionals. We always need to have the if, so it's required. Both else if and else are optional. We don't need them in order for our programs to work with a conditional. For quantities, our if, we need to have one, but we can only have one in any given sequence. We can have as many else ifs as we want, all connected together, and we can have one else at the most. We can have anywhere between 0 and 1. And since we're using whole numbers to represent else's here, we can either have 0 or 1 else. We can't have more than one else, and I guess we can't have negative else's. All right, that all makes sense, y'all? Cool. All right, folks, that is our lesson.